Hello, CSEC students. Welcome back to another live class. Today we're going to be looking at the theorem and a rule regarding a circle. So we're going to look at some of those rules, the most relevant ones to the CSEC syllabus. So we're going to look at 5 of the circle theorem rules, and there are others. Said if you know 5 inside out, you'll be able to manage circle theorem questions that are going on the CSEC exam. So I'm going to start doing just a quick one of the 5 rules we're going to be looking at, and then I'm going to go through each rule more in depth. So remember, when we're talking about a circle, we all know what a circle is, right? It's a series of points that rotate a central point. The circle at the center is 360 degrees. When we're doing angles in CSEC, we are not usually given a simple circle and say, okay, calculate an angle here, or you're usually maybe you're given a circle with a triangle inscribed on the inside, or some kind of quadrilateral on the inside of the circle. So it's a little more complex than just a simple circle like you get in the lower grades with a missing angle. The circle up into sectors and you have your missing angle. So you have to know that the circle certain shapes described within the circle. Set 5 of the circle theorems, and the first one says the angle at the center of the circle is twice the angle at the circle. So I should take the opportunity here to remind us. I'm going to take the opportunity. Hold on. Let's see if I can quickly get some circle. So ourselves what we're talking about when we say the circumference, the radius, the diameter. Just a quick revision. All right, so here we have 3 rules, right? So we know what we mean when we're talking. So the circumference, when we say the circumference, we mean the distance around the all the way. In other words, the circumference is perimeter of the circle. This word here, the circumference, is the distance around the of the circle. Now, a chord is that runs from one end of the circumference. So once a line starts on one end of the circumference and touches another end of the circumference, so that's a chord. Now, there's a special chord in the circle called the diameter, and it cuts the circle into two. So the diameter goes up. It doesn't have to be horizontal. We could have it from top down. So that's a straight line. So the diameter could be diagonal in any direction. So once it's the circle into two equal parts, that line, that circle chord, is called diameter. The radius is half of the diameter. So in other words, since diameter is a line that cuts the circle into two halves, and the radius diameter. So then to draw the radius, we start at the center and go anywhere. So that's a radius. That's a, and we draw countless radii. So plural radii, or we could still say radiuses, right? So radii, so one radius. So the radius is a half of the diameter. This is the diameter. Is that we have two radii, we have two lines from the center of the circle going out to the circumference. What we have created is called sectors. So we automatically have created two sectors. So this is the minor sector, the smaller one. So that's the minor sector. And this will be major sector here. We also have created an arc, or we should say two arcs. So this is the arc is the distance along the circumference. It's a fraction of the circumference. So this is the minor arc, and one over here would be the major arc. So we have minor sector, major sector. The sector that's along the circumference, that will be the minor arc and the major arc. Now let's go back to the chord. The chord cuts this circle into segments. So this would be a segment here. So just radii cut the circle into chords of the circle into segments. So here we'd have a minor segment, and all of down here the major segment focusing. So this chord cuts the circle into a minor segment and a major segment. All right, so now that those things out of the way, so let's go back to this circle theorem. So the first theorem, angle at the center is twice the angle at the circumference. We're going to go in depth in each of these. All right, those guys on the chat, welcome. Dinsmore, I'm seeing Carissa, I'm seeing Jamani. So the theorem says the angle in a circle is our angle. The angle in a circle measures 90 degrees. The third says the same segments are equal. All right, so I'll explain what all of these mean. Number 4, opposite angles in a cyclic quadrilateral sum to 180 degrees. So the opposite angles in a cyclic quadrilateral should add to 180 degrees. And the theorem 5, the angle between the chord and the tangent is equal to the angle of the alternate segment. Angle between the chord and the tangent is equal to the angle in the alternate segment. So let's go through each of these one by one, and then we can look at some activity and to see if we really understand what the circle theorems are all about. So we're going to theorem 1, and we're going to go more in depth. Oh, sorry, skip. To go to. Okay, so theorem 1. The angle at the center is the angle at the circumference. All right. So we have two angles here that we're focusing on. This angle center. This is the angle formed where, so we have two radii coming out. Two radii coming out and forming this angle. And here we have the angle, the circumference. So this angle comes down, it starts and it touches both ends. So the two angles actually have to touch each other at the ends. The ends of the angles have to touch for this rule to apply. So the angle that starts in the, and the angle that starts at the circumference, they need to meet each other at another section of the circumference. So what they're saying is that if this here, let's say that angle was 34 degrees. This angle here is 4 degrees. This one would be 2 times that. So this one would be 68 degrees. Automatically. So even if it is not given, we can put it in because we know it should obey that rule. And many times when you are given circle theorem questions, you're not going to be told, first of all, you're not going to be told which of the theorems you are to use, right? So get that straight. You are expected to know the theorems and you're expected to analyze the diagrams and see what you can fill in. What are you not told? What do you know that you can fill in? And that will lead you further now to solve for missing angles. So they might ask you for an angle, but you need to fill in something first before you are able to find that angle. And what you're able to fill in would come from your knowledge of the circle theorems. So they might give you this angle here at the circumference, and they ask you, what is this one here? You know that the circle theorem states the angle at the circumference is half the angle at the center, or the angle at the center is twice the angle at the circumference, whichever one you're given, because you might be given any one. They might give you the angle at the circumference and ask for the center, in which case you're going to multiply by 2. Or they might give you the angle at the center and they want the angle at the circumference, in which you'd have to divide 2. So you really have to know what you're doing. You have to know what the rule says. The one at the center is the bigger one. So if you get the one at the circumference, multiply by 2 to get the one at the center. If you get the one at the center, divide by 2, get the one at the circumference. All right, so let's move on to another theorem. The second theorem, the angle in a semicircle is a right angle. The angle in a circle is a right angle. So remember I said the diameter divides the circle into 2 halves, so into 2 semicircles. Therefore, once you have a diameter, it's a diameter, they will indicate that it's the center of the circle, it runs through the center, or here you see in this case the 180 degrees. So that's a clue also that this is a straight line running across the circle. So once a circle, an angle starts anywhere at any point along the circumference and it touches both ends of the diameter, that angle is automatically a 90-degree angle. It's a right angle. So all you need to do is to verify that the angle is indeed touching both ends of the diameter. Once the angle starts on circumference and touches both ends of the diameter, you don't have to ask any further questions. You know this is a right angle here. All right, so let's go on to the next theorem. Theorem 3, angles in the same segment are equal. So remember we said chords cut the circle into segments. Now, if you look at these 2 angles, actually we have 4 angles we could look at here. Angle C and angle D. These 2 are equal because they start on the circumference and they end the same chord. So another name for this angle, another way of explaining this angle is that angles on chord are equal. So sometimes you will see that this theorem stated in that way. Angles in the same segment are equal, or angles on the same chord are equal, because see the 2, so this angle comes and touches that same chord. This angle comes in and touches that same chord. So whatever angle C is, angle D is the same. So if angle C is 15 degrees, angle D is also 15 degrees. Likewise, angle E, this angle here, is also equal to angle B, because the 2 of them also end on the same chord here. The chord isn't there, but you can see that from this point to that point would form a chord. Just like how I drew the chord here. So over here, what we have is it's a situation that you'd likely get. This is the way you would likely get it. You have these two angles here, and they are angles in segment or angles on the same chord. So we know these two are equal. So they might give loan, right? They might give angle C and tell you what it is. And then they might ask you to find this angle here, D, as well as this angle here. So these two rules coming into play now, you know. So you would use this theorem to find D, because you'd say, all right, C and D both end on the same segment, or they are in the same segment, they end on the same chord. So C and D are equal. So whatever they gave you for C, so let's say that C was 70 degrees. You would know automatically that D is also 70 degrees. But then how are you going to find here? You want this one also. So we'd have to go back now to the theorem that we did first, number one. The angle at the center is twice the angle at the circumference. So here we have both angles touching each other on the circumference. This one starts here, this one starts in the center. So this is 2 times that. So this will be 140 degrees. And this is how you're likely to get a circle theorem question. One-off thing, but you're able to get a combination of shapes and a combination of the theorems. And you might have to use one to find something and then use another one to find something else, or combine them. So you have to be on top of your game. The fourth theorem, angles in a quadrilateral sum 280 degrees. Okay, so opposite angles. Okay, opposite angles in a cyclic quadrilateral add up to 180 degrees. What is a cyclic quadrilateral? So we know that from we hear the word cyclic, it indicates we are going to be with the circle. All right, so that part of it is covered. We're dealing with the circle. And what's a quadrilateral though? A quadrilateral. So the root quad, the root word quad means 4. Lateral means side or length. So a quadrilateral is a 4-sided figure. And we have a number of quadrilaterals. The square is a quadrilateral. The rectangle is a quadrilateral. The rhombus, the parallelogram, the trapezium, the kite, all of those are quadrilaterals. So whenever you have a 4-sided figure enclosed within a circle with all vertices of that quadrilateral touching the circumference, and this is important, all the vertices of the quadrilateral touch the circumference. If they don't all touch it, this rule does not apply. That's very important. All the points of the quadrilateral must touch the circumference. Whenever we have that occurring, the opposite angles in the cyclic quadrilateral should add to 180 degrees. So what are opposite angles? Angle C is opposite to angle E in this quadrilateral here. So C and E are opposite. B and D are opposite. So if C is 84 degrees, then angle E would be 180 minus 84 degrees, which is 96 degrees, because opposite angles in a cyclic quadrilateral add up to 180 degrees. Likewise, if we know either one of these opposite ones, so let's say this one is 75 degrees, this one would have to be 105 degrees. Take the 75 from 180. Opposite angles in a cyclic quadrilateral should add up to 180 degrees. So let's look at the fifth theorem that we're doing for today. There are other theorems. We're only doing this one. These five, sorry. So this one says the angle between the chord and the tangent is equal to the angle in alternate segments. Okay. So the angle between the chord and the tangent is equal to the angle in the alternate segment. We already defined the chord, so we know this is a chord, this is a chord, this is another chord. So which of the chords are they talking about? Well, they did say the chord and the tangent. What is a tangent? So a tangent is a line that's coming in. It's like a comet coming in towards a planet. So if you imagine the circle as a planet, and if you imagine the tangent as a comet just coming in and grazing the planet, just grazing it, just touching it at one point, and going away into space again, right? No damage done, just coming in and touching. So this is a tangent. This line is called a tangent. So a tangent is a line that comes in and touches the circle at one single point here. So this angle between the chord and the tangent is equal to the angle in the alternate. So remember, the chord cuts the circle into two segments. This will be the minor segment and the major segment. So if we started talking about this angle between the chord and the tangent, so the alternate segment would be over here, right? Talking about this. So if you know this, or if you through your working out, if you found this, you automatically know this. Or if you were given this one, or you worked out this one, you automatically know this because they are equal. And what you generally find in the CSEC is that you will be given, so you'll be given a question, and then you'll see I. So I might want you to find angle A, and then I might want you to find angle B. And what you usually find is that those angles that you find first, they usually enable you to find the ones coming after. So my advice to you is, when you find any angle, part A, you find an angle, part B, you find an angle, just scribble them in on the diagram, so you'll know that, okay, I knew this already. Because if you just look at the diagram as given, you might not remember that you had already worked out a particular angle, and you might be thinking that, well, I can't find this one because I don't know enough information. So as you work the question coming down step by step, whatever you're asked to find first, just put it in, whether in pencil or you're going to sketch a rough diagram, just fill it in somewhere so that you'll know what information you have already, and that will help you to find new angles that you're asked to find. So what we're going to do now, we're going to just do some activity to test out knowledge of the theorem. And I'm actually start with for me, this is the simplest one of the theorems, and we're going to demonstrate. But before I tell you which one we're demonstrating now, I want to just draw the angle and ask you. Let me ask you to in the angle for me. Say,
Miss your meter.
Students are saying they're not hearing me. Are you hearing me? On my end. Indicate to me, please, if you can hear me. All right, so I'm not muted on my end, but some students saying they're not hearing me. So let me start that out. Let me sort that out in a minute. Okay. All right, so you are hearing me. All right. Okay, so let's continue. All right, let's continue. Okay, so let's say origin. Degrees. I want you to find those two missing angles and why. So it's two missing angles. To tell me what is x, what is y. How many degrees? How many degrees does x measure? How many degrees does y measure? Based on the theorems that we just discussed. All right, so tell me what is x and y. All right, so Dinsmore is saying y is 90 and xc. I would also like it if you would tell me why you say that. If you want, just tell me which. Just sum it up. You don't have to write out the entire theory.
Give a minute, please.
So let me see. All right. So Dinsmore, y is angle in the semicircle with 90 degrees. All right, that is correct. And how do you know that's a semicircle? So Dinsmore, you need to tell me, how do we, are we assuming or can we prove it? What is it on this circle gave us the clue dealing with a semicircle? All right, so we know it's the diameter because we see that O there. That O represents the origin. So whenever you're looking at the circle, and this means this angle here starts at the origin. This is the center of the circle. So we know this is the diameter. I mean that this is the diameter. We know this is the right angle because it touches both ends of the diameter. All right, so Dinsmore got that down. So we know this is a 90-degree angle. Dinsmore is also saying, well, miss, since I know this is degrees and I know this is 10 degrees, and I know that the angles in a triangle must add up to 180 degrees. So I just have to add 10 plus 90, which is 100, and take it from 180. So we have 80 degrees. All right, so that's awesome. Okay. All right, so let's do another one. Okay, so I want this angle here. That's all I want is that angle. And W. Okay, so find W for me and tell me, when you tell me what W is, tell me how you get that. How you get W to be that angle. So let me see some answers coming in. All right, so what's W? All right, Dinsmore, so you're the bright today. What Dinsmore is saying, W is 5 degrees. Why is that? All right, so Dinsmore says the base angles in an isosceles triangle are equal. And how do we know that this is an isosceles triangle? And since the angles are equal, but we are not told what the angles are, even if we know they are equal, how did we determine that that is 45 degrees? What is the clue that is given? What is the clue that is given that lets us know that we're dealing with an isosceles triangle, first of all, and that the base angles are 45. We can't just assume, you know. You need, sometimes in the CSEC, you're asked to explain, give a reason for your answer, especially in problems like circle theorem. You to give a reason for your answer. Why do you say so? The O here tells us that this is the origin. Therefore, we know that this is the diameter. Therefore, we know that this is a right angle. That's 9. Since we know we have 2 strokes here, 2 strokes here, that's what tells us that this is an isosceles triangle. Once you see these 2 strokes, it means these 2 lines are equal. Therefore, these 2 angles. So if this is 90 and the full triangle adds up to 180 degrees, so from 180 is 90, and then that's in 2. So each of these is 45 degrees. That's how we know. We're not guessing. We're not assuming. We're using the fact. So the O tells us this is the origin. Therefore, we know this is the diameter. Therefore, we know this is 90 degrees. Therefore, we know that these angles must add up to 90 degrees. We know that these 2 lines are equal. Therefore, these 2 angles are equal. Therefore, we split the 90 degrees between them. All right. So look at this other circle now and tell me give me the missing angles. I want you to give me angle X, and this angle is, let me see, 196 degrees. So if this angle is 96 degrees, X okay, all right. So I'm just seeing your answers coming in. So and Imani were telling me that because they see the strokes, that's how they knew that. Sometimes the chat lags, so I wasn't seeing your responses. All right, so how do we find angle X in this? we know one of the angles is 196. All right, Imani is saying 98 degrees. How do we know that it's 98 degrees? Which one of the theorems are we relying on for this one? All right, so that would be theorem 1, which says the angle at the center is twice the angle at the circumference. Therefore, angle X, half of 196 degrees. So angle X would be 90. Imani is correct. The angle at the center 2 times the angle at the surface. All right, so how about this one? So if let's say this is 30 degrees. What is this angle be? That one is 30 degrees. What's the here? So the same rule applies. The angle at the center is twice the angle at the circumference. However, this gave us the angle at the circumference. We are to find the angle center. So rather than dividing, this time we need to multiply by 2. So X would be 30 degrees times 2, which is 60 degrees. All right, so 60 degrees. Moving along. All right, so that's 20 degrees. And that's 10 degrees. So X and what is Y? And also what is, let's call this M, and that's the origin. All right, so Y and M. So give me some ideas here. X, how do I find Y? How do I find M? I wish the chat wouldn't lag so much because sometimes the answers come in long after we pass that down the road. So this is the question we're at. I want to find X, Y. So you guys need to catch up with the chat. Come on. Come on, guys, in the chat. Run, run, run. All right, so Dinsmore is ahead of the game here. Dinsmore is saying it's not 25 I have up there now. Dinsmore is 20. It's not a 5, it's a little circle, it's a little 0. So Dinsmore is saying the theorem that we would use is that angles in the same segment are equal. Therefore, X is the same 20 degrees, Y is the same as the 10 degrees. So what is M then? What's M? All right, and Imani is saying the same thing. X is 20 degrees, Y is 10 degrees. So 20, 10. Okay, so Dinsmore is saying it's 40 because the angle at the center is twice the angle at the circumference. Okay. So let's move on. All right, so here's another simple one. You can just tell me this off the bat. What would be? All right, so that one is pretty simple. So likewise, this we just using the same segments are equal or angle same chord are equal. Therefore, X will be the same 32 degrees. So Imani is asking if we would all angles and multiply by 2. I'm not understanding what I don't know what you mean, Imani. Add all angles in this on the circle, multiply by 2. Not sure what you mean by all angles on the circumference. Dinsmore is telling me to use different colors, but no matter, I keep switching up the colors, and Dinsmore still can't see. I don't know which other color Dinsmore. I've been seeing them up, I still can't see them. So x is equal to 32 degrees. Did I write in the answer for the one before? Hold on. Okay. So x is 20 degrees. Y is 10 degrees. Iman, if you could explain for me, because I'm not sure what you mean. All right, move on. Let's do some of the cyclic quadrilaterals. So remember, they must touch all points. Each point on the cyclic quadrilateral is circumference. As a cyclic quadrilateral, it's a four-sided figure within a circle. All right, so this is 79 degrees. This x, and this is 100 degrees, and this is w. So I needed to find x and w. What is x? What is w? So the angles we have within this cyclic quadrilateral, the angle at the top there is 79 degrees. The angle adjacent to it is 104 degrees. How do we find x and w? So this now applies to the cyclic quadrilateral. So since opposite angles in a cyclic quadrilateral add to 180, so w is opposite to the 104 degrees. So w would be equal to 180 plus 140. So w would be 76 degrees. And 79 is opposite x. So x to 180. So x would be 180 degrees minus 79 degrees. So that gives 100 degrees. All right, so let's do one last one. All right, so tell me, what are these angles? All right, these two angles. Actually, I want all the angles. I want to know all the angles. So Imani got 104. 180 minus 79. What did I have? 76 or 79? 29. So it's 101. All right, so quickly, last one. How do we find all those angles? All right, so remember the opposite angles of a quadrilateral add to 180. Therefore, for the x, the 4x plus 6x would add to 180. Four x and 6x would give 10x. Therefore, it would be 180 divided by 10. So x is 80. All right. So since this is 4x, if x is 8 degrees, so 4x would be 72 degrees, and 6x 100 degrees. These two, they're opposite to each other. They both add up. For the y and the 3y and 2y. So again, they must add up to 180. So 3y give 180 degrees. So 5y give 180 divided by 5. $36 degrees. Since that's 2 times 36, this is 72 also. Therefore, we know that the other one is 108, but let's just check. So the 36 times 3. So this is also 108 degrees. All right. So that's the wrap for circle theorem. Like I said, there are other theorems. So we did 5 ones. Once you master, you'll be good to go. The CSEC exam. All right. So remember, we have our live days later on, especially the midnight oil class. Don't miss that class. We're going to be doing 60 multiple choice questions. All right. See you there.